Hello dear students, welcome you all to the JC eConnect series of online lectures. Today in module 3 we are going to study types of loads. In previous video lectures we have studied the types of supports and types of beams. So continuing further, let us understand which are the different types of loads which will be acting on the beams in this topic. So, the different types of loads are: first is a concentrated load or a point load, second is uniformly distributed load UDL, and third is uniformly varying load UVL. Now, let us try and understand all these three types of loadings one by one. First is the point load or the concentrated load. It is the type of load which is concentrated at a single point on the beam. So, point load, as its name goes, or the concentrated load, it is that type of load which acts at a single point on the beam. Now, here we have P1, P2, P3 are the point loads, N is the Newton, which is the unit. Either point load can be in Newton or kilonewton, and L1, L2, L3, L4 are the locations of these point loads on the beam. So, point load is very simple to be considered in analysis. If the point load is acting downwards, it is taken as negative. If it is acting upwards, it will be taken as positive. But here what happens is, generally all the loadings on the beam will be acting downwards only. You don't have a point load in maximum cases which will be acting upwards or act from the bottom of the beam, because all the loading will be put on the top surface of the beam itself. So, these loads will give rise to a reaction which we will be finding in the problems when we solve them. So, when we take an example of a point load, so this can be an example for the point load. You have a beam, say we will name the ends AB, 10 Newton, 15 Newton, 22 Newton are the point loads at the given distances from the left and the right support respectively. Then comes the next type of load, which is UDL, or the uniformly distributed load. This is the type of load which is distributed over the span of the beam uniformly. Okay. Now, understand the word uniformly distributed load means the load is distributed uniformly over the given span. For example, if you take the tiles which are there on the floor, it can be taken as an uniformly distributed load because the tiles are uniform in shape and size and weight, and they are distributed throughout the room. Okay. So, this is what is a uniformly distributed load UDL. So, the schematic representation of this goes like this: W kilonewton per meter, and the load is throughout the span. Now, it is not that it should be over the entire length L, it depends as per the given question. So, this is what is your uniformly distributed load. It is that type of load which is uniformly distributed over a given span. Now, most important thing here is the unit. If W is the UDL, its unit will be kilonewton per meter, whereas the unit of point load was just kilonewton. So, here we will have a unit of kilonewton per meter or Newton per meter, but when it is a point load, the unit is only kilonewton or Newton. So, many times we find students getting confused or making a mistake here. So, please try and understand what is an uniformly distributed load. It is a load which is throughout the given span, it remains constant. Intensity at each point on that given span is the same. Now, let us consider one example of an UDL. Now, this. Now, how will we read this? We will read it as a UDL of 12 kilonewton per meter acting over the entire span of the beam, which is 6 meters. Okay. Now, we have to learn how we convert this UDL into a concentrated force for analysis. Okay, when you have a UDL, we need to convert it into concentrated force and then consider it for analysis. Now let us study how to do it. Intensity of UDL as a concentrated force. Intensity or the word magnitude can be used. Magnitude of the UDL as a concentrated force. What do you mean by concentrated force? It is a single force, okay, or a point load or a point force. It's only one, whereas UDL is a number of forces of uniform intensity acting together. Okay, so now here we'll try and convert this UDL of 12 kilonewton per meter into an equivalent point load. How it is done? It is done by using the formula W into L into L by 2. Now what is W? Intensity of the given UDL, which is 12. What is L? Length of the beam. L by 2 is half. That means when we convert an UDL to the point load, it acts at the center of that span. Okay, this is one more important point which you note. When we convert an UDL to a point load, where it will act? It will act at the center of that span over which it is acting. Single force will act at the center and its intensity will be W into L by 2, where L is the span over which UDL is acting. Okay, L is the span over which UDL is acting. Now in above case, what will we get? 12 into 6 into 6 by 2, which comes out to be 216 kilonewton. Okay, if we convert this UDL into a single force, it becomes 216 kilonewton, which acts at what distance? L by 2, that is half of 6, which is 3, either from left or right support. This is how we convert an UDL into an equivalent point load. So friends, here what you can do is just take some simple examples. Take a beam of say 8 meter span. Take a UDL of intensity 20 kilonewton per meter. Find the equivalent point load. Okay. Then next case, take a beam of 12 meter span. Take a UDL of 10 kilonewton per meter. Find the equivalent point load and its location. So if you become perfect in this, applying this concept in the problems becomes very easy. Okay, so how we convert an UDL to a point load? We multiply W into L by 2, where W is the intensity of the given UDL, L is the span over which it is acting, and multiplied by L by 2, that is half of the span. Now where will this equivalent point load act? It acts at the center of that span. So if you want to represent it in the form of picture, it goes like this. So this UDL on the left hand side, okay, this one is equivalent, this is the equivalent sign to the single point load which is applied at what distance? It is the center of this given beam, because UDL is acting over 6 meters, 6 ka half kitna? 3. Okay, so this is how we convert an UDL into equivalent point load. Hopefully the concept is clear to you all. Now let us go to the next type of loading, which is a bit tricky. Now this type of loading we term it as UVL, or uniformly varying load. As per the definition, it says this type of a load is the one which varies along with the length. UDL was constant throughout the length, whereas UL will vary over the given span. So generally it is in two types of shapes. The left one, this is the triangular shape, where you see that load is going on reducing. Either this can be from this side or this side also, not an issue. Both are UVL only. So this is one in the triangular shape, where at the end the load becomes 0 and at the base the load is the maximum. Okay. Second form is a trapezoidal shape type, where we get a trapezoidal shape and the last point does not have 0 intensity, but there is some value. But this load also is uniformly varying. Now the difference is here the last value becomes 0, whereas here the last value does not become 0. So there is a need to understand both these types because those are asked in the question paper problems. So what is a uniformly varying load? It is that type of a load which varies uniformly. Okay, it varies or it changes uniformly along the span. So here also W kilonewton per meter will be the intensity. Again, as UDL, UVL also is given by the unit kilonewton per meter or Newton per meter. So understand these both figures. So in the next slide, we can try and convert now these UVLs into equivalent point loads which are required for analysis.